Hello everyone, I'm Leah Crowe, and on behalf of Hanson Johnson and myself, I'm going to be talking to you all today about some tools we've developed using the R programming language, and specifically the R Shiny package. The tools I'll be talking about are currently used to aid in the process of implementing protection measures for North Atlantic right whales. So in the US and Canada, there are currently dynamic management strategies in place that rely on the ability to quickly implement conservation measures in response to detected right whale presence. And so what this means is that when whales are seen or heard, those detections are communicated through a series of channels that may ultimately result in ship speed slowdown areas and/or fishing closures. But a lot happens in between detection and implementation. So, for example, survey teams that are out sighting right whales have to process their data so that it's in a form that can be used by managers. And for some teams, they've been out for an entire day, and some of them have seen a lot of whales. So it can be kind of a tough task at the end of a day when you have a lot of data that you have to compile. And those sightings are then communicated. This is often done through email or a web-based portal. And then a decision has to be made on if those detections trigger a management action. And if they do, then that zone has to be calculated. And in the US, I'm going to use the example of the right whale slow zone program, which is the dynamic version of the seasonal management areas, which all of these programs are used to help mitigate ship strike issues. And so seasonal management areas happen at the same place at the same time every year, but when right whales are detected outside of those zones, a dynamic zone can be put into place where ships are encouraged to reduce their speed to 10 knots or less. And so with changing right whale distribution and occupancy shift changes in the last decade, this has created a lot more attention to dynamic management measures as the whales have been seen outside of existing protection zones. And so far this year in 2021, these data were actually pulled at the beginning of September. We've issued more than 40 right whale slow zones already. And if we look at this in the context of the entire program, this is more than we've ever issued in a year. And of course, this program, well, not of course, but this program has been bolstered by the integration of acoustic detections. And so you can imagine going forward that having more eyes and ears out listening and looking for whales may mean that we just continue to issue a lot of these zones. So having a process in place to help streamline this and make it more efficient is really helpful. And so to do that, some tools have been developed using the R programming language and the Shiny package that help this process, but also offer interactive web-based data visualization. And so along this timeline of detection to management zone implementation, you can see where some of these apps lie. So Whale Map is primarily used in Canada, but it also integrates sightings, effort, and acoustics data throughout right whale, the range of the eastern seaboard and the Atlantic. And the Northeast Fisheries Science Center survey app is really involved in data processing of aerial survey effort by our team, and also generating a report to help or that's sent out to stakeholders to detail the findings of the survey. To aid in the decision-making process, the Northeast Fisheries Science Center Trigger app is used to evaluate sightings in the Northeast region, so from Virginia to Maine. And so this looks at both visual sightings and acoustic detections to determine if a dynamic management area slow zone is recommended. And so in that last slide, it may look like Whale Map and the NEFSE survey app are kind of redundant, but they really do work together and integrate within this process. So sightings are coming from all directions, and Whale Map is really the tool that's visualizing all of this for us. But I do want to iterate at this point that there are still a lot of people involved. There are people answering phones and emails. There are people pressing the buttons, and there are people evaluating if the results from these tools make sense and ultimately making those final decisions. But what these tools really do is automate these repeatable processes that we do. Like, for example, the NEFSC survey app helps get our data into the form that we store it in our database, as well as the form that we submit to the consortium database. And ultimately, these apps have products that are shared with managers, so getting data into the format that is most helpful for getting dynamic or implementing dynamic measures. So the real benefits behind using these tools are that they help improve efficiency, makes the process more reproducible, and impartial and consistent. So it doesn't matter who's pressing the buttons. You should get the same answer between different people. The process is transparent. All of the code is available on GitHub. It makes these processes more convenient than some of the ways that we've done this in the past. And R and Shiny are completely free. So they're publicly available for anybody, and it just alleviates that need to interact with a contract with a developer for a long period of time. And these tools are accessible for non-computer science people. Neither Hanson nor I are formally trained computer scientists, and a lot of the people that we've relied on aren't computer scientists either. So there is really a great community, both for us in our respective workplaces, but also online. And so just for a quick spin of the Northeast Right Whale app. So the user can specify the day, and basically what this is doing is pulling in data that we collect off the airplane, both sightings, effort, and GPS data, allowing a space to see what that all looks like. And in these tables, they are editable, so if there's something that needs adjusted or edited, they can do that in this interface. The data can be exported, and then this final map shows the survey in the context of the currently active management zones. So you can see the seasonal management areas as well as the right whale slow zones, which are the dynamic ones. And then a report can be generated from here, which is what gets emailed out to stakeholders, which is basically the information on the map as well as details on the sightings. And then the last step here is to see what's going on with these right whales if they meet the trigger criteria for a new dynamic management zone. And that happens over here in this tab. So here we can see the blue is the recommended zone that from these sightings and how they're oriented to each other essentially. And this box gets automatically generated with the boundaries as well as the name based on the nearest landmark. And then the output here is a report with that information as well as a preform letter to Garfo. And then quickly with Whale Map, it's this visualization of survey effort as well as the sightings that occurred. You can also see acoustic gliders and buoys are on here, and any acoustic detection, whether it's definite or possible, is also detailed. In addition to right whales, there are other species data available here that can be explored, and the user can define what time period they're interested in and a summary at the bottom. So a lot of options depending on what you're interested in getting more information on. So all of the code is on GitHub. check us out. Also, we're giving a workshop at the Society for Marine Mammal Conference next year to help people develop these kinds of tools for themselves to help streamline that process between detections and interacting with managers to hopefully save some people some time. And thank you to all these folks. And for further information, check out these resources. Thanks.